It is a detailed plan. So the researcher designs his or her research. And why should he design it before actually conducting it? The design would guide it, would help him to guide it how to proceed, and the design helps him to provide and to get the answer to research question. So the researcher starts with a research question, I have told you. So research design enables the researcher to answer research question in a valid, accurate manner. Okay. So research design has two basic purposes: to provide answer to research question and it guides the researcher how to collect data for testing the to collect the data and to so that the researcher can control the variance. Okay, so the research design has two basic purposes: to provide answer to research question and to control the variance. We know we have how many types of variance are there? How many types? We have systematic variance. Variance, you know, the degree to which the scores vary. Okay, so the individuals vary among themselves. That's why they obtain different scores. The subjects or the sample, the participants of the research do not get the similar score. Their scores vary. So there is variance. Their scores have a variance. So we have three types of variance. We have independent variable and dependent variable. We are trying to find out the effect of independent variable on the dependent variable. We are going to test whether any change in independent variable is associated with any change in dependent variable. Okay, so variance, this variability in independent variable and dependent variable, we are going to study it. We are interested in it. Variance of independent variable and dependent variable, or variability in independent variable and dependent variable. We are interested in it. We are systematically varying the independent variable and studying the variability in dependent variable. So the variance in independent variable and dependent variable, which is the focus of our study, is known as systematic variance. Okay. Apart from independent variable and dependent variable, we have extraneous variables which may also influence the dependent variable. So we have to control the variance of extraneous variables. Extraneous variables should be controlled. So extraneous variables should be controlled. Why? Controlled means it should be the effect of extraneous variable should be eliminated so that we can attribute the change in dependent variable to the change in independent variable. Okay, so extraneous variance or variance in extraneous variable, extraneous factors are also there. Second type of variance. And third type of variance, I have told you, we are measuring the individuals in terms of the dependent variable. Okay, we are taking a measurement of the dependent variable. I have told you, any observed score is the combination of true score and error score. So obtained score is true score plus error. So there is always some amount of error. Okay, so there are some error variance. So we have three types of variance, and the research design, our research design helps us to maximize the systematic variance, to control the extraneous variance, and to minimize the error variance. Okay, so in short, we may remember it as max mean con. Max mean, max max, min mean, con. Maximize the systematic variance, minimize the error variance, and control the extraneous variance. Okay, so our design, the aim of our design, objective of our research design is max mean con. Okay, before discussing the various designs, research designs, let us be familiar with some terms, some terminologies. We should get familiarize ourselves with some research terminologies, which words we will come across again and again. Okay, so in research we use a term known as factors. Okay, factors. Have you heard it? Factor?
Yes, ma'am.
Have you heard it? What is a factor?
Factor is known as
Yes.
a situation like
What?
or something, a situation.
Ma'am, factor is a component that has some influence in that proper relevant process.
Yes, in research context, in simpler term, we can say that a factor is the independent variable of an experiment. Okay. In our experiment, our independent variable is our factor. Okay. So we may have one independent variable at least if we are going to conduct an experiment, we have at least one factor, at least one independent variable. We can have also more than one factors. Okay. So another term is label. Label. What is a label? Have you heard the word label?
Yes, ma'am. When the independent variable is administered in three different types or two different types, it has two different levels.
Okay. A label is a particular discrete possible value. It is a discrete possible value of the independent variable. Okay. We have an independent variable. Our independent variable can have different values. Okay. These possible values are known as labels. In simpler term, we may say that a label is a subdivision or subcategory of a factor. Okay. So the factors have subcategory, and these subcategories are known as label. In a simple experiment, suppose we are going to compare males and females in terms of their heights. Okay. So here our independent variable is gender, isn't it? Our independent variable is gender. So gender is our factor. Okay. And within the factor, within the gender, we have two subcategories, males and females. Okay. So we have two labels. Clear? So are you clear?
Yes, ma'am. We are
Yes,
clear.
ma'am.
Okay.
Yes, ma'am.
So number of subcategories of the factor are known as labels. Okay. So in an experiment, we should have at least one factor, and which has the factor has at least two labels. Okay. So we have at least one factor, and the factor has at least two labels. If the factor has one label, it is not a factor. Okay. And third terminology which we are going to discuss is a treatment. Treatment refers to a particular set of experimental conditions. Okay. We are exposing the subjects to treatment conditions. Depending upon how many treatment conditions will be there, depends on the your factor and levels. So treatment is our set of experimental condition. Suppose, how do we express it? You know, we have to write the research report in a prescribed format so that others can understand it. So how do we write it? If we have, suppose, two factors, okay, and each factor has two labels, okay, so we write it as 2 into multiplication sign 2 into 2. Okay, the design is 2 into 2. That means anybody and we say it or we read it as 2 by 2. 2 by 2. Though we write it as 2 into 2, we read it as 2 by 2. We say it 2 by 2. So anybody sees wherever it is written that 2 into 2 experimental design, he or she will understand that there are two factors and each factor has two labels. Okay, and if we have a 2 by 2 design, then we have 4 treatment conditions. Okay, each independent variable is a condition, experimental condition, isn't it? And each label is also experimental condition. So we have 4 treatment conditions. Okay, so treatment is a particular set of experimental conditions. Clear?
Yes, ma'am.
So let us start our designs. Our design depends on the number of factors. Okay, first I have told you that we must have at least how many factors? How many factors? We must have
2 factors. 2 factors.
we must have at least one factor.
3.
An experiment. We must have at least one factor, at least one independent variable.
Yes, ma'am.
Do you have any doubt?
No, ma'am.
Suppose I am going to study the effect of gender on the intelligence. Okay, so intelligence is a dependent variable. Okay, gender is independent variable. So here we have a single factor. We have one independent variable. If we do not have any independent variable, can we conduct the experiment?
No, ma'am.
So there has to be at least one independent variable. Okay, at least
Yes, ma'am.
one. So, and each factor must have at least 2 labels. Okay, remember it. So first we should start with experiments involving one factor only. Okay, so how to design an experiment in which there is only one factor, only one independent variable. We name them as single factor design. Okay, single factor design. That means we have only one independent variable. Suppose we have an experiment in which we are going to find out the difference in academic achievement of students coming from urban colleges and coming from rural colleges. Okay. What is the independent variable here? how many independent variable are there?
One.
One. What is it?
College.
College.
Rural and urban
How
college.
many levels?
Yes.
How
Two
many levels?
levels.
How many levels are there?
Two
Ma'am, two
levels.
levels.
2 levels.
One,
Yes.
one is rural,
Very good.
one urban.
Very good.
Urban and rural.
Very good. So here we have a single factor we design. We will plan a single factor design. Okay. Single factor experiment. In this case, we are going to compare students coming from urban college and students coming from rural colleges. Okay. So we are going to take two different groups of subjects, isn't it?
Yes,
Isn't
ma'am.
it? We are going to
Yes.
compare two different groups of students. So there are two different groups and we are comparing them in terms of the dependent variable. Okay. So it is known as a between group design. Okay. Between group design. That means we are making a comparison between the groups. Okay. We are taking two different groups and we are making a comparison between the groups. So when we are taking two different groups of students, we have a between group design. In a true experiment, remember yesterday I told you there are some characteristics of a true experiment. First, randomization. Okay. We are assigning, there is a control group and there is an experimental group. We are assigning the subjects to experimental group and control group randomly. Okay. So in a true experiment, we are randomly assigning the students to experimental group and control group. Our experimental group is receiving the both the groups are receiving two different types of treatment. Okay. And we are comparing them into for their dependent variable. So when we are actually conducting a true experiment, we have to randomly assign the subjects to experimental group and control group, and we have to manipulate. The second characteristic of a true experiment is manipulation of independent variable. The example I gave you, the comparison of male and female or the comparison of urban and rural college students is not a true experiment. Why? We cannot randomly assign a subject to rural college or to urban college. We have to select them from the urban college or rural college. So it is not a true experiment. Uh, we may say that it is a quasi experiment or anything we have discussed. So in a true experiment, suppose we are going to find out the effect of knowledge of result on the rate of learning of school students. Okay. of the school's students in a particular city, say Cuttack. Okay, you all of you, I think, are from Cuttack. So in your city, we are going to investigate the effect of knowledge of result on the rate of learning. Okay, so here the independent variable or the factor is knowledge of result, and the dependent variable is rate of learning. Okay, we have to take two labels of the independent variable. So one, we may take first label is knowledge of result is given, second level is it is not given. Okay, am I clear?
Ma'am, please
Yes, ma'am.
explain again.
We are going to find out and the effect of knowledge of result on the rate of learning of school students of Cuttack. Okay, so here we are we have the independent variable. We have one independent variable, that is knowledge of result. Okay, we have to manipulate it. Okay, and dependent variable is rate of learning. So independent variable is knowledge of result, and we have to manipulate it. So we have to make subcategories of it. We have to give knowledge of result to one group, and we have to knowledge of result will not be given to other students. That is how we are going to manipulate it. We may also add we may give partial information regarding their knowledge. We may add groups also, labels. Okay, for simplicity, let us take two labels. Okay, now we have two labels. We are manipulating the independent variable and making two labels. First, so according to the labels, we have to take two groups. Okay, because we decided to manipulate the knowledge of result, one group will be given the knowledge of result, and the on the other level, at the other level, no knowledge of result will be given. Okay, so the group which is given the knowledge of result, which is provided with the knowledge of result, is called the experimental group. Okay, and the group which is not provided with the knowledge of result is called the control group. Okay, so here we have two different groups. What we are going to do, we are randomly selecting 100 students from school students, say class 9 students from Cuttack. Okay, different schools are there, Cuttack. We may select randomly 100 students. Okay, you know how to collect a random sample. All of you know, I suppose.
Yes, ma'am.
We'll do it later. Okay, later on we'll discuss it. First, we take a random sample and randomly assign or randomly divide these 100 students into two groups. Okay, with 50 students in each group. One group will be provided with the knowledge of result, that will be the experimental group, and The other group, no knowledge of result will be given to the other group, and the second group is known as the control group. Okay. So here we have randomly assigned the subjects into two groups, and we have manipulated the independent variable. So it is an experiment. Okay, it is a, we may say, a field experiment, or we may call them and conduct the experiment in laboratory also. So here we are comparing two different groups. Okay, and we have one independent variable, we have two labels of the independent variable, and we are taking two different independent variables. Two different groups. Clear? The groups, the subjects receiving the knowledge of result, and the persons who are not receiving the knowledge of result are different here. So we have two different groups, and this type of experiment or research is known as between group designs. Okay, if clear now?
Yes, ma'am.
Okay.
Yes, ma'am. Yes,
If,
ma'am.
so remember it, while conducting actual research, our use of statistics depends on the research design, and we have to use statistics in order to interpret our data. Statistical analysis, we have to go for statistical analysis. So statistical technique depends on our what? Choice of design. So here we have a between group design. We have two randomized group design. After the collection of data, here we have to conduct, or we have to go for which statistics? Any idea?
Ma'am, it's maybe a 2 into 2 factorial design, like contingency table chi-square.
Why 2 by 2 means we have two independent variables, and each independent variable has two labels. Here we are going to find out the effect of knowledge of result on the learning rate of the students. How many independent variable do we have?
One
One.
independent variable is there.
Variable. So we should not go for 2 by 2.
Ma'am,
Okay.
keep
Ma'am,
it.
should we go for correlation?
We are here discussing about single factor designs. Okay. I have discussed the experiment. Here, I have discussed the experiment with you. I took a random sample of 100 school students. Okay. Randomly
Yes, ma'am.
assigned them to experimental group and control group. The experimental group was provided with the knowledge of result, and the control group, to the control group, no knowledge of result was given. Okay, that's how we manipulated the independent variable. Understood?
Yes, ma'am.
Then we compared the rate of learning of both the groups. Okay,
Okay.
we measured the rate of learning and compared them. How we should go for comparison? With the help of statistical technique.
Yes, ma'am.
So here we have two groups, two different groups,
Yes, ma'am.
isn't it? We have
Yes, ma'am.
two different
Yes,
groups.
ma'am.
So
Yes,
here
ma'am.
we have to go for between group T test.
Between.
Between group T test. Okay.
Okay, ma'am.
Um, you will be taught statistics. I think you have a paper also on statistics. So all of you are familiar with T test, I suppose so. So we have
Yes, ma'am.
um, between group T test where two different groups are there and we are comparing them. Okay. So we will use between group T test. This is on the parametric statistics side. For parametric statistics, we the data must have in at least interval scale. So if our rate of learning is measured on an interval scale, then we will go for t-test. Okay. If our data is not in interval scale, is a lower level of scale, it is in a lower level scale. Either it may be in ordinal scale. Then we will go for Mann-Whitney U-test. Okay. If nominal, it is in nominal scale, we will go for chi-square. So the statistics we are going to use here is between group t-test or Mann-Whitney U-test, depending on the level of our measurement of the dependent variable. Okay, clear? Are you clear now? If you have any doubt,
Yes, ma'am.
ask me.
No, ma'am.
I
I don't have any doubt.
I want all of you to design a research and choose the appropriate statistical technique independently without anybody's help. So if you have any doubt, please ask me. Okay. Should we move?
Yes, ma'am.
Here we have our independent variable has only two labels. Okay. Information about result is given, is not given. We have only two labels. Suppose we give partial information to some subjects. Okay. One group will be given full information about their result. The other group is not given any information, and we will add a group. We will give them partial information. Okay. Suppose then we have three groups, we have three levels of the independent variable, isn't it? Three different experimental situations: full information, partial information, no information. Okay. So we have three levels of independent variable. Got it? Clear?
Yes,
Yes,
ma'am.
ma'am.
Do you have any doubt?
No, ma'am.
Okay.
No,
So
ma'am.
we have added here another experimental condition. So now we have three different labels of the independent variables. So we have three treatment conditions and we have three different groups. Okay. In that case, what we will do, what statistics we will use? We have three different groups.
ANOVA.
Yes, one way ANOVA. Okay, one way ANOVA. And if our data is not suitable for parametric statistics, we may go for Kruskal-Wallis test. Okay.
Yes, ma'am.
So, in our likewise, here we added another group, so we have three different experimental situations. Okay. Likewise, we may go on adding independent labels. We may have four different experimental situations. We may have five groups, etc., and so on. We can add labels to our experiment, can't we? We can add on labels. Do you have any doubt about it?
No, ma'am.
No, ma'am.
Okay. So we may, if we go on adding, we will have more and more experimental or treatment conditions. So we will have more number of groups. Okay. So there will be more number of groups, 3, 4, 5, or a number of groups, and we will here go for analysis of one-way analysis of variance. And if our data is not suitable for parametric statistics, we will go for Kruskal-Wallis if it is in ordinal scale. Okay. So this is.
So, ma'am, in this case, the design will change.
Yes, you are asking something.
So, ma'am, yes, ma'am. I'm saying that in this case, in the three dependent variable, the design will change.
No, the design is still the single factor between group designs. Single factor between group design is there, but our labels are more. Since our we have more than two
But, ma'am,
labels.
in single.
Yes, we have a single factor. No, we have one independent variable.
But, ma'am, here we are three independent variables.
Three dependent variables. How?
Three
What are your
independent variables.
No, your independent variable is knowledge of result. You have three labels of the same independent variable. You have
So
only
one
one
independent variable is there and it has three levels.
Yes. You have, what is your independent variable? Independent variable is,
The cause.
Result.
and your independent variable has three labels. Variable is not going to increase. Variable is remains
Okay.
one. So, since you have only one independent variable,
There is only one.
single factor design, and since you are taking different groups, you have
The label will increase.
only the label will increase, means the treatment conditions are increasing, so you are adding more and more subjects to your study. You are adding more and more groups. Okay.
Okay, ma'am. Thank you, ma'am. Please
So
continue.
you have still single factor between group design. So our objective is to max min com maximize the
Systematic variance.
systematic variables and control the extraneous
Extraneous variable.
variables. Okay.
Yes, ma'am.
Error variables will be there and yes, you are saying something.
Yes, ma'am.
Yes,
I'm saying,
ask me whatever you want to ask.
hello, ma'am.
Sumitra, are you asking something?
No, ma'am. I'm just
Okay.
saying that we have to minimize or error variable.
I cannot hear. Please ask. Please speak louder. I cannot hear you. Sorry.
Hello.
Hello. Hello.
Ma'am,
Am I audible?
yes, ma'am.
Yes.
Am I audible to you?
Yes. Yes. Now you are audible.
Ma'am.
I can hear you. Sorry, Sumitra, I can't hear you.
Okay, ma'am. You please continue.
Okay. So, how to control the extraneous variables? So, here our research design also should suggest us ways to control the extraneous variables. We have several designs. First, matched group design. When we are taking randomized block designs, we are taking two groups. We may match the groups in terms of extraneous variables. So, all the extraneous variables kept constant. Kept constant means they are affecting both the groups in similar manner. Okay. So its effect in dependent variable is kept constant. It is controlled.
Yes, ma'am.
Okay. So how to keep them constant? We have to match them. Match the subjects. One way of matching the group is to take to adopt a matched group design. Okay. In a matched group design, all subjects are first tested on a common task. Okay. And then they are formed into groups. Okay. On which common task they are first tested. Suppose two persons scoring same. So if we have two persons obtaining the same score, we put one of them to experimental group and the other to the control group. So both the persons are matched in terms of the task we have tested before administering the dependent variable. Okay, clear? We
Yes.
test all the subject on a common task. Okay, then we divide the persons obtaining same score to experimental group and control group. Okay, and which what common task should we administer? It should be a task which we believe that it might be influencing our dependent variable. It should be related to dependent variable. So in our experiment of knowledge of result and rate of learning, suppose our intelligence, rate of learning also depends on intelligence, isn't it? Intelligence also influences our rate of learning. So we have what we should do, we will administer all the subjects an intelligence test. Okay, the persons scoring or obtaining same score on this intelligence test will be assigned, will be divided into, one will be assigned to experimental group and one will be assigned to control group. Suppose two persons obtain 100, or we administer the standard progressive matrices to all the subjects. Two persons obtained 40. So one of them will be assigned to experimental group and the other will be assigned to control group. Two persons assign 38. Two persons obtain 38. One will be assigned to experimental group and the other will be assigned to control group. Okay. Four persons score 44. Okay. So there are two pairs of students obtaining the same mark. So two of them will go to the experimental group and two of them will go to the control group. Okay. So here we match the subjects in terms of a variable. So the matching variable is different from the variable under study. Here we are interested in rate of learning. Our dependent variable is rate of learning. So we will match the subjects on a variable, different variable other than the rate of learning. Okay. So it should be different from our dependent variable, but it should be it is believed to be influencing our dependent variable. If it is not influencing our dependent variable, why should we control it, match it? Okay. So if we believe it to be influencing our dependent variable, then only we can control it. This is an extraneous variable and we can match control it. So we will match the subjects in terms of it. Okay. Clear? Got it?
Yes, ma'am.
Yes, ma'am. Are you saying the pre-test?
Yes. What were you saying? What are you saying?
Ma'am, is it same as a pre-test design?
No, it is not same as the pre-test design. I will discuss the pre-test design. It is a matched group design. Here the matching variable is not same as our dependent variable or the variable in which we are interested. Okay. We are our variable of interest is rate of learning, but the matching variable should not be the rate of learning. It should be different from it, and it should be believed to be influencing it. Okay.
Okay, ma'am.
Okay. But in actual practice, we may not get such pairs of students scoring equal marks. Always it will not be possible. Okay. If matching by pairs is always not possible. So what should we do? We will go for matching in terms of mean and standard deviation. Okay. We should match them in terms of mean and standard deviation. We may administer the standard progressive matrices to all the subjects. We may take subjects within a range. Suppose students scoring between 35 to 45 will be selected. Okay. So that in both the groups, the standard deviation is not very high because we have restricted the range. We have selected the subjects scoring between 35 to 45. Okay. And divided them to two groups. Got it? So here the means we are matching the subjects in terms of mean and standard deviation. Since we have selected the subjects scoring between 35 to 45 and divided them into two groups, both the groups should obtain a mean which will be within this range, 35 to 45. It will be around 40 for both the groups, isn't it? All the subjects are selected have scores between 35 to 45. So we have restricted the range of the scores and we have randomly divided them into two groups. So maybe one group will have a mean of 39 and the other group will have a mean of 41, like this. So the means will be very close. They will not be very much different from each other. Okay. So we are matching the subjects, matching the groups in terms of mean and standard deviation here. Actually, in practice, we match the subjects in terms of means and standard deviations. That is how we control extraneous variable. Okay. Control the extraneous variable variance. Got it? So we can have paired matched groups. We can match the subject groups in terms of means and standard deviations. There is another technique also. We can match the groups in terms groups statistically. We have not matched them in the way I explained you, but I use statistical techniques to match them, to parcel out the effect of intelligence here, our extraneous variable. Okay. So there is a statistical technique called ANCOVA, ANCOVA, statistical technique to match the groups or to control the extraneous variables. Okay. So there are three ways to control the extraneous variance. Got it? Got it?
Yes, ma'am.
Okay. So we discussed about between group single factor between group design. Here we have one independent variable and we have different groups of subjects in each treatment condition. Okay. There may be conditions where we have to use the same subjects. Okay. Suppose we want to introduce a new method of teaching. Okay. A new method of teaching and study whether it improves your rate of learning or not. Okay. You are clear about the research problem?
Yes, ma'am.
We are going to test a new method of teaching. We are going to find out whether our new method of teaching is by new method of teaching, say that knowledge of result. Okay, we can also do it like that. We will use the same subjects. We first give them previously no knowledge of result was given. We will test all the subjects. Okay, and then we give them the knowledge of result of their performance. Then again we study them, test them whether their rate of learning increases or not. Okay, got it?
Yes, ma'am.
And if we may another experiment, we may want to study the effect of colors on reaction. Okay, so we may select three colors, say red, green, and yellow, and let us measure their reaction time to these colors. So these same subjects here are exposed to three different treatment conditions. Same subjects are exposed to red color, the same subjects are exposed to green color, and the same subjects are exposed to yellow color. Okay, same subjects, same group of subjects, they are exposed to three different treatment conditions. Clear? In our knowledge of
Yes, ma'am.
experiment or new method of teaching experiment, what we are discussing now, forget about the between group design where we were taking two groups of subjects. We are discussing about a new design where the same group of subjects will be exposed to the different treatment conditions.
Ma'am, is this within group design?
Yes, I am going to tell you that this is within subject design. The same group of subjects are
Okay, ma'am.
in different conditions. Okay, so
Okay, ma'am.
this is within group design, or we call it as repeated measure design. Okay, repeated measure. Why repeated measure? The subjects are repeatedly tested or repeatedly measured in terms of the dependent variable. Okay, that's why it is called repeated measure design. And why within subject design? We are making the comparison within the group, not between the group. Okay, we are not taking different groups and comparing them. We are taking the same group and exposing them to different treatment conditions and comparing the performance of this particular group. Only one group is there, and we are comparing the performance of this group on these three or two different conditions. Okay, so it is within subject design or repeated measure design. So as in between group design, there can be two labels or two conditions in within group design, or more than two multiple conditions. Okay, so we may have two or more than two conditions. Here in within group design, there is a difficulty. What is that? Suppose we are testing the in our rate of learning experiment, or we are going to find out the effect of a new method of teaching on the achievement of students. Okay, so we are testing the subjects before the new method is introduced. Okay, again after the new method is introduced, we are testing the subjects again. Okay, so since the same subjects are tested twice, there may be carryover effect or practice effect. The first testing, in the first testing, the subject is familiar with the task, so it is very likely that the subject will perform better in the second testing. So here there may be carryover effect. Okay, practice effect. The change in the post test, post intervention test jota, and the post test, the change in post test may be actually due to the practice rather than your new method of teaching. It is possible. So we have to control the order or sequence of these treatment conditions in a within subject design. If there is the possibility of carryover effect or the sequential effect, then we have to counterbalance. You must have had counterbalancing design, counterbalancing the experimental conditions, ABBA design. Have you heard counterbalancing? In counterbalancing, several conditions are presented only a few times. Then we can use it in a reverse order. Okay. So counterbalancing to control for order is done to control for the order effect or the sequence effect of sequence of conditions. Suppose we have three conditions, three treatment conditions. We are interested in finding out the reaction time to different colors. We have three different colors, red, green and yellow. So we have stimulus subjects in red color, in green color and in yellow color, and we are going to find out the difference in their reaction time to these different colored objects. So we have three different treatment conditions, say A, B, C. We say A for red, B for green and C for yellow. So if we have three different conditions A, B, C, we can have 6 different conditions of these treatment orders. 6 different combination of orders. Okay. We have ABC, we have ACB, we have BCA, we have BAC. Like this, we have 6 possible sequences. Okay, got it? So each participant in our experiment is randomly assigned to one of the 6 sequences. Here, if we can do this, we can control the carryover effect. Okay, got it? Understood? Understood? Clear?
Yes, ma'am.
Okay. So to control for the sequential effect or order of presentation, effect of order of presentation of treatment conditions, we have to counterbalance the treatment conditions like this. So let us make a comparison of between group and within group designs. What are the differences? First, in between group design, one subject receives only one treatment. We have 2 different groups, so each subject receives only one treatment. Okay, in within group, each subject receives a number of treatments depending on the levels of the independent variable. In between group design, pre-existing intergroup differences, the groups may be different before coming to the experiment. Okay, both the groups may be different, so there may be pre-existing differences which is a source of error. As I told you, there may be differences in their intellectual level. If we do not control them, this is a source of error. Okay, but within group, since we are measuring the testing the same group in conditions, there is no pre-existing intergroup differences because a single group is there. So, such intergroup differences and within group differences are sources of errors in between group designs. Whereas these are not sources of errors in within group designs. In within group errors designs, the sources of errors, what is the source of error? The order of presentation of conditions. Okay. So, chances of practice and carryover effect from one treatment to subsequent tasks or treatment conditions is possible, is there. Chance is there in within group design. But in between group design, since we are taking two different groups, chances of practice or carryover effect is not there. Each subject is tested once only. So there is no chance of practice effect. But in between group subject design, since we have to take separate subjects in both the conditions, we need more number of subjects. Okay, more number of subjects. Whereas in within groups design, we are testing the same subjects in different conditions, so we need less number of subjects. Okay, and another difference is in between group design, since each subject is tested once only, less time is required, and in within group design we have to wait until each subject is tested in the pre-test condition, then again we test them in a different condition, so we have to wait for it and we need more time. And in within group design, since the same subjects are to be tested several times, a limitation or a difficulty is there. The same subjects may not be available. They may not be interested to be tested again and again. They may leave the experiment. So there is chances of attrition. Okay. So, are you now clear about the single factor designs between group and within group designs?
Yes, ma'am.
Yes. Okay. We discussed about the experiments when there is only one independent variable. But we can have also more than one independent variable. 2, 3, 4, we can have more than one independent variables. In that case, we have to go for factorial designs. If we have more than one independent variables, we have to go for factorial designs. We will use factorial designs. Okay. I have already told you, if we have two independent variables and each independent variable has two levels, then we have a 2 by 2 factorial design. if we have three independent variables and each independent variable has two labels, then we have 3 by 2 factorial design. If we have three independent variables each having three labels, then we will have a 3 by 3 factorial design, and we write it as 3 into 3, though we say it as a 3 by 3. Okay. Let us be familiar with some terms here. If we have a factorial design, that means we have more than one independent variable. There are two types of effects. Okay. In a single factor design, there is only one effect of the independent variable or effect of that single factor. Okay. Now, in factorial design, we have, suppose we have two independent variables. Okay. A and B. We have two factors A and B. Suppose A is our gender, B is our socioeconomic status. Suppose. So A and B. It can be anything. So what are the possible effects? There can be an effect of A, gender differences may be there. Okay. So there may be gender differences across the socio-economic status groups. In each socio-economic status group, there can be gender differences. So gender differences are there across the socio-economic status, across the SES groups. So we have effect of gender across all the levels of SES. Okay. We call this, or we term it as the main effect. Okay. When we have the effect of an independent variable across all the levels of the other independent variable, we call it as a main effect. Okay. So a main effect is the effect of a particular one independent variable averaged across all the levels of the other factors. Okay. So we can have a main effect of A here, and we have the other independent variable B. So we can also have a main effect of B. Okay. So these are main effects of both the independent variables. And there is also another possible effect, interaction effect. Interaction means that the effect of one independent variable depends on the level of the other independent variable. Okay. The effect of one, try to understand. Actually, in experiments, we are interested in interaction effects in most of the experiments or research. These are very interesting, interaction effects. and I have examined several cases. I have observed that people are very afraid of interaction effects. If interaction effect comes out to be significant, people become phobic. They are a phobia of a significant interaction effect. Researchers are afraid of, but it is not something to be afraid of. It is very interesting. Okay, so try to understand. If you understand it, it is very interesting, and you can interpret it very easily. So interaction effect means the effect of one independent variable is different at different levels of the other independent variable. Okay, the effect of one independent variable is different at the different levels of the other independent variable. Okay, so if we have two independent variables, gender and ACS, we have two levels of gender, male and female, and we have two levels of ACS, high ACS, low ACS. If our interaction effect is significant, it may be can be explained like this: the gender effect or gender effect of gender in the high ACS group is different from that in the low ACS group. Okay, among the high ACS subjects, there may be a gender difference, and among the low ACS groups, between the low ACS groups, the gender difference, there may not be any gender difference. In low ACS group, males and females may be equal, and in high ACS group, there may be a gender difference. Or the opposite also may be true. Among the high ACS group, gender difference is absent, and among the low ACS groups, gender difference is present. That is, the effect of gender is different in different levels of ACS. It is there in gender differences are there in high ACS group, and it is not there in low ACS subjects. Got it? Got it?
Yes, ma'am.
Yes, ma'am.
Ma'am.
So, we can discuss another example. Suppose we have two independent variables. We have two categories of students: high intelligent and low intelligent students. So our ability, intellectual ability, is one independent variable, and we have different teaching methods. Our second independent variable is our teaching method. Say lecture method and discussion method. If our main effect of teaching method is significant, then both the teaching methods would yield significant differences across all the ability groups. Okay, there will be differential effect of teaching methods among low intelligent group as well as high intelligent students. In both the groups of students, there will be difference in differential effect in the teaching method. That is main effect. But if our teaching method into ability, intellectual ability, interaction is significant, then it may be, the result may be such that the differences in teaching method is there in one ability group, it is not there in the other ability group. Okay. Or it may be different. Among the high intelligent group subjects, the discussion method may be yielding better result, and among the low intelligent level group of subjects, the lecture method may be showing better results. Okay. So this is interaction effect. How can we know that an interaction effect is significant or not? If we suppose we have 4 groups, if we plot one independent variable in graphs, okay, suppose plot graphs for it. What we do, we have 2 independent variables. So actually when we present it graphically, what we do, on the x-axis we take one independent variable. So our x-axis represents one independent variable. Okay, say A. Okay. So x-axis, on the x-axis we will plot A. Okay. On the y-axis, what we will plot? All of you know how to present your result graphically. On y-axis always we plot the dependent variable, isn't it? Am I clear?
Yes, ma'am. Yes, ma'am.
On y-axis we plot dependent variable. On x-axis we have plotted one independent variable, that is A. We have
Yes,
still
ma'am.
another independent variable B. Where
Yes, ma'am.
we'll plot it. We will plot different lines for B1 and B2. Okay. So we have B1 at A1, we have B1 at B2. 2 points, isn't it? If we had a blackboard, I could have shown it to you. So if we have 2 points, A1, B1, B1 at A1 and B2 at A1, and we have also 2 other points, B2 at A1 and B2 at A2, and we join both the B1 points, and so it makes a line for B1 and make a line for B2. Okay, so there are 2 different lines, B1 and B2. Got it? Understood? We have A plotted along the x-axis. Along the y-axis, we are plotting the dependent variable, and we have two different lines for B1 and B2. Okay. If the both the line, we can also take B1 plot B along x-axis and make different lines for A. We can also do that. If our interaction effect is significant, then our both the lines, we have two different lines for B1 and B2. These two lines, if the interaction effect is not significant, both these two lines will be parallel to each other. Okay. And if the interaction effect is significant, the lines are not parallel to each other. Okay. They may cross each other or they may not cross each other. They may, the difference between the lines may change, but they are not parallel to each other. Okay? Got it?
Yes, ma'am.
Okay. So, coming to factorial designs, we have 2 by 2 factorial designs. We have factor A and factor B. Factor A has two labels, A1 and A2, and factor B has also two labels, B1 and B2. So we have 4 combinations. Okay, A1 B1, A2 B1, A1 B2 and A2 B2. Okay, 4 combinations, possible combinations. Okay, and we have, so there are 4 possible treatment conditions, and we have to analyze the variance, the total variance among these treatment conditions. Between these treatment conditions, within these treatment conditions, we analyze the variance. What we do? Suppose our factor A has no effect. Okay? Suppose our factor A has no effect. Then our A1 should not be, the variance between, difference in variance between A1 and A2 should not be significant. So all our A1 groups and A2 groups should not differ from each other. If our A has no effect, if our A has no effect, then our A1 and A2 should not be different. It is difficult to get it.
Yes, ma'am.
As we were discussing in single factor experiment, if our independent variable has no significant effect, okay, if it has no effect, then our experimental group and control group are not different from each other. Okay, isn't it? If our
Ma'am, I'm still not getting.
think of it. Suppose we think about the single factor design. We are trying to find out the effect of one independent variable, that is A. Okay, if A has no we are manipulating A. So experimental group condition is A1 and control group condition is A2. Okay.
Yes, ma'am.
So if A has no
Yes, ma'am.
if A has no effect, then our experimental group and control group are not different from each other.
Yes, ma'am.
Then A1 is not different from A2.
A2. Yes, ma'am.
Both A1 and A2 are same. They do not
Yes,
vary
ma'am.
from each other.
Yes,
They
ma'am.
do not vary from each other. So there is the variance of variance between A1 and A2 is not significant.
Yes,
They do
ma'am.
not vary from each
Yes,
other.
ma'am.
The variance is not much. The variance is not significant. Okay.
Yes, ma'am.
The same
Okay, ma'am.
thing here in factorial design. We have a factor A and we have two levels A1 and A2.
Yes, ma'am.
So if A is not significant, A1 is not, if A is not significant, is not different from A2.
Yes, ma'am.
The only difference is that we have introduced another independent variable B1. So our A1 constitute two groups, A1 B1 and A1 B2. So our A1 condition consists of two groups, A1 B1 and A1 B2. Our A1 is one level of A. Okay. Among the boys, there may be high SES boys, but there may be low SES boys. So, and among the girls, there are high SES girls and low SES girls. Got it? Both boys and girls have high SES and low SES members.
Yes, ma'am.
Yes, ma'am.
So, if gender has no effect, then boys are not same as boys are same as girls. If gender has
Yes,
no
ma'am.
effect, boys are not different from girls.
Yes, ma'am.
Okay, ma'am.
There may be high SS and low SS students within each group, but boys are same as girls. Okay.
Yes, ma'am.
Ma'am, here the
Similarly,
gender differences matters.
hmm?
Ma'am, here the gender
Yes,
differences is matters.
the main effect of A. A means here we have our gender. Okay.
Yes, ma'am.
So if gender has no B means our SES. Okay. We could have conducted another experiment to find out the SES differences. The effect of SES on the dependent variable. We could have done it, but here we have combined two experiments into one factorial design experiment. Okay. Actually, we could have
Yes.
conducted two separate experiments, but we are combining two experiments into one. At the same time, we are finding out the effect of gender and we are also finding out the effect of SES. Okay. So we are combining two experiments. That's why it is a factorial design. Why we are not going to conduct two experiments? We are preferring one experiment experiment with a factorial design? Because if we will go for 2 experiments, there will be more error, type 1 error, which you will be taught in your statistics class. There will be chances of type 1 error, more type 1 error. And secondly, if we go for 2 experiments, we will need more subjects, more time, isn't it? দুইটা experiment କରିବାକୁ বেশি সময় লাগিব. We will need more time.
Yes, ma'am. Yes,
Will
ma'am.
be more. If we can find the effects of both the variables at one time, it will take less time, it is easier, isn't it?
Yes, ma'am.
Yes, ma'am.
Okay, so I mean it is
Ma'am,
like
it's like a combo offer.
पेस्ट के साथ साबुन फ्री है. Okay,
Yes, ma'am, it's like a combo offer.
yes, it's like a combo offer. So another very important advantage is there. If we conduct 2 experiments, we cannot find out the interaction effect, interaction between SES and gender. We cannot know. And if we go for a factorial design, we can know the interaction effect. And it is very important advantage of factorial designs. Okay, got it?
Yes, ma'am. Yes, ma'am.
And like the single factor design between group and within repeated measure, we have also, when you go for factorial designs, we can also go for between group and repeated measure design. We may take different groups of subjects and expose them to different treatment conditions, or we may take the same group of subjects and expose them to different treatment conditions. So we can also have repeated measure factorial designs. Okay, we can have also mixed design. Means we have in a factorial design, we have at least 2 independent variables. For one independent variable, we take different groups of subjects, and for the other independent variable, we measure the same subjects, or we expose them to different treatment conditions. So it is the mixed group or a mixed design. We say this like 2 by 2. Yes. Yes.
Ma'am, am I audible to you?
Yes. You are asking something?
Ma'am, yes, ma'am. In two-factor design, sorry, ma'am, in factorial design, the interaction effect is lower or higher?
There is a chance of getting an interaction effect. It may not come out to be significant, but there is a chance of it being significant. But if we go to different experiments, we cannot know about the interaction between the 2 independent variables. If we test them simultaneously, so chance of getting the interaction effect. So we have factorial design, we have repeated measure factorial design, and we have mixed factorial design, where one independent, there are between some different groups for one independent variable, and For the other independent variable, there are the same group of subjects are studied. What are the advantages of factorial design? So I have already told you, advantage is that we are able to manipulate and control two or more independent variables simultaneously. So in fact, we are doing two or more experiments simultaneously. Okay. So it is more precise. It is more, it is less time consuming, and the most important advantage is there. We have the chance of finding out, we have the scope of finding out the interaction effect. Okay, we can know the interaction effect of interaction of the two or more independent variables if we go for a factorial design. And what are the limitations? What are
Ma'am,
the
in case of large experimental design or when we have a large group of treatment conditions, it becomes very difficult for the researcher to get
Yes,
a homogeneous sample.
yes, you are right. The experimental setup and statistical analysis become complicated, and it is also it becomes difficult to interpret if we have a large number of factors. Okay, if we have a large number of factors, we will have a large number of interaction effects, and it is actually difficult to interpret them. So researchers usually go up to they are very comfortable with two factors and three factors. Sometimes they go for four factors also, but very rarely they would opt for more than four factors, because it will be very difficult to interpret the results. Okay, so rarely they go for four factors, but more than four factors are very rarely used. Okay, now can I assume that you have understood the single factor and multi-factor research clearly?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So, I think we should stop here, and we will discuss the other types of research, other designs tomorrow. Okay,
Thank you,
Yes,
ma'am.
ma'am.
these are experimental type of research we have discussed. We have also non-experimental types designs. So we will discuss it tomorrow, and tomorrow we will also discuss about the qualitative research. Okay.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Okay,
Thank
ma'am.
you
Thank
for
you, ma'am. Have a good day.
listening to me patiently.
Thank you,
Yes,
ma'am,
ma'am.
for
Thank
teaching
you.
us and sharing your
Hi.
experiences.
And so have a wonderful day.
Have a good
Same to you,
You too,
ma'am.
ma'am. Have a
Thank
good day.
you.
Thank you. Goodbye. We will meet tomorrow.
Yes,
yes.
ma'am.
Okay, ma'am.